we had run this campaign called Ask Tarry on several social handles, and we got a overwhelming list of questions from people. We've shortlisted about 6 questions out here, and we'll be open for 2 more questions from audiences, but this is going to be a Q&A session where we will be asking Tarry a bunch of questions. So are we all ready for that?
Thank you.
All right, so this question is from Dilip, and the question is that a major part of success in AI is due to the tech being available now to implement it versus a few years ago, right? So the cost of tech is going down, neural network, computing power is going up. So what, according to you, are some of the ideas and applications from AI for 2019 and 2020 that will have a great going?
Okay, so I think image classification, probably you're seeing already. So you have a lot of examples. If you use TensorFlow, probably not much in PyTorch or other different libraries, but you already see, so image recognition, image classification, Amazon Go, kind of, even industrial scale kind of solutions in which, it almost seems like, getting closer to the Black Mirror kind of world in which, you walk in, there are no people, and you can already sort of, take stuff, purchasing is done automatically, everything is all interconnected. So I think that world is advancing. Not to say that is it advancing, I think only Amazon or just a handful of companies are doing that. So I think in the next 2 years, if Flipkart or other companies, or even, regular sort of companies with maybe, maybe a lot of access to this, open data set, but not the engineers, they will probably have a problem doing that. So they should be adopting this. So actually, I want to turn this question. Nothing is just going to happen on its own. Okay, so I mean, it's not like we're sitting here and we can be here in 2020, and if we don't do anything, nothing is going to happen. So I think what I think is possible, that's all I can talk about. It's possible to already start using the proven methodologies to use image classification in different areas. I would say, it could be anything. Scene segmentation, where you see a 3-dimensional space, you can already start making sort of meaning and sense. You can see those things. So they will be more interestingly used in the next 2 years, I think. For example, if we had taken, or if the organizers had taken your permission, to which you would have said, well, it's a closed experiment. We just want to observe how often you yawn or close your eyes, okay? You don't tell who you were. Or in your emotion, body language, if you were enjoying this show or not. So that's sort of a very interesting way to understanding as well. And that's scene segmentation. You should read those papers, and there you will be reading really interesting papers that speak about also the temporal sort of memory and hierarchies, actually. You'll find connections there. So I think, so in terms of the computer vision, there will be many new applications and extensions of deep learning. In text analytics, what I foresee is that, so we've seen data sets being used, huge trained data sets like AlexNet, BGG 16, 19, all these things, which are trained data sets to work on your specific problem where you have limited data set. That is image. But I think in the next 2 to 3 years, you will have a lot of trained data sets on text. I think that's a huge revolution coming. That's like amazing. So all that data that you have in your enterprise, all that data that you have in your healthcare records, people don't know what to do with, it will start becoming simpler. It still looks complex now. Image, I mean, if you're a deep learning engineer, someone says, well, I have 20,000 images, and I have like this, you already know what to ask questions, you know what to do with them. In text, it's still complicated. So I foresee that more extension of computer vision in the next couple of years, hopefully in different sort of industry areas. And with the help of, already there's a data set being released from Google's Universal Sentence Encoder, USE. That's what I think is something which Google, what was that, on Google I/O, you had this assistant talking and making that was not Alexa, that was the Google Assistant, and it was doing things like, and that stuff. And that is all coming from that sentence encoding structures. And that is based on the data set. I tested that as well, and I have one on my GitHub as well. You can check it out. And there's a small data set for that text down there. So that is going to be coming as well. Long answer, sorry.
Thanks. Okay, so then the next question is, so this is like a classic question. Will deep learning bring in more jobs? If no, what's your suggestion to the ones losing their jobs to AI and automation?
Well, I think I said that at the beginning already. You should be transitioning anyways to understanding what deep learning is. Whether you're a manager, well, I'm a mid-40s guy. I was a manager and director doing different things in my career in the last 10 years. I mean, I've had mathematical physics and all different kinds of astronomy and different kind of academic background, but I didn't use it. So I would say try to adopt it, and I think the job loss is going to come inevitably. So as more and more these data sets are going to come, there will be automated solutions. So if you do not change and become that person who brought that automated solution within your own company, you are extinct. So I think it is in a way kind of becoming the usurper, as in you become that sort of enabler of that technology. So it is almost like calling. I would say, really, please take it seriously. I took it seriously. It's helping me. Because I had a state in my own job, no matter how cool, director or VP, it would have gone. I mean, I was head of AI and machine learning and artificial intelligence in my company. But essentially, I realized there's some huge breakthrough coming. I had to quit that job, which seemed interesting, but actually we were not doing much stuff there. So right now, we are really doing amazing stuff. So I would say a job loss or a job, let's say, correction is definitely underway. It's already happening. I mean, there's tech companies, I don't want to name names of companies because in Bangalore, there have been like thousands of pink slips being given on a regular basis. It's coming because they're losing clients in Europe and the US because those clients are adopting AI and ML solutions. So I think you should really adopt that and probably you'll avoid this job depletion scenario.
Cool, thanks. So then the next one. So this is a slightly personal question. What has been one of the most critical challenges that you've faced in your journey so far, and how did you overcome it?
Oh, that's a great question, Shweta. I think it's kind of also rather open-ended question. I think so. The most critical challenge is actually believing in yourself, and when you are doing a regular job, when you have a regular pay slip coming. No matter how meaningless the job is, you still kind of you chug along, and you sort of stop believing in what you actually are capable of. And today I feel I'm capable of so many things, and so I had to let my guard down. I had to be less sort of defensive and more vulnerable, but I had to be vulnerable in a situation with people who loved and cared for me, and they were not co-workers or colleagues. Unfortunately, that's reality. I mean, eventually, if you have a colleague, he's competing for a job or a promotion or a project. So they're not the people who can support you emotionally. So for me, it was, well, okay, so I know what I'm capable of, but I don't believe in myself. So I think, to me, that was really the hardest challenge to overcome. So how to find way to believe in yourself while you can do it, and that's probably the biggest hurdle that people face. The steps that I took is, well, I quit that job. That's a pretty radical step because I hated that job. I'm sorry if my ex-employers listening to it, but that's the truth, guys. I hated that job. I was, not really enjoying it. It was not helping my health. So the first was quitting, second was taking a step back and detoxing, third was finding sort of meaning by talking, as I mentioned, to people. Some run billion-dollar enterprises, and been fortunate to have introduction to it. Learn from them how they have managed and what they're doing, and travel, and then you start seeing recognition in peers who come in different forms and shapes. So I think that really helped me. So basically, you can stop. I'm not saying that you should quit your day job. You should not. but find yourself in your job as well by finding that meaningful project will give you some hope. And if sometimes there's no hope, then you have to take some radical steps. So I had to take radical steps because I thought there was no hope. And now I'm having a lot of fun. So, but I had to go through this sort of difficult tunnel with no lights in it.
Okay, cool, thanks. The next one, this is a learning related question, right? So there's so much of content online, on deep learning, on machine learning, all of that, right? So how not to get lost in the ocean of data science learning material, and how can somebody finally make a transition? What
Great question. So I just kind of say, how many people really experience, this is really a good question, isn't it? Yeah, it is crazy, I can tell you that. And yesterday I shared with some of you from PyData, that how to organize your mind and just follow a bunch of meaningful researches and not jump into archive or bioarchive where you can read a whole lot of stuff on neuroscience, and there's a Git archive as well, which is also collecting stuff from GitHub. So there's a way to filter it. There's it's an interface created by one of the engineers from Tesla. He used to teach also at Stanford ML courses. So I shared that link with the group. I can share it here as well. It's called Sanity Archive or something like that. I keep forgetting it. I call it Sanity Archive.
Archive Sanity Preserver.
Archive Sanity Preserver. Perfect. Thank you. So that's the way to kind of organize your research and just stay in that area, not get lost, because getting lost is really a problem. 2, learning. I will, in next few weeks, I'm going to be in Dallas, in San Diego, talking about how to kind of organize it. So how I did it is, I said, okay, I have fundamental understanding of probability, I have fundamental understanding of advanced math, I have fundamental understanding of statistics. So these are the things you need to have in your toolkit at the back of your head. Now once you have that, then you can say, okay, so what do I do? Can I do something with machine learning? And try to just focus on 1 or 2 areas. Don't try to go into those 12, 15 different techniques in ML. If you go into boosting or XGB, gradient boosting, some people just live and die for it because, I saw, I think it was GoPro. That's a camera company, GoPro. So one of the head of GoPro was like super excited about XGB, and then they were naming it even longer and making it funny names. But you can be passionate about something in ML, and if it is, then you should do that. But try to still focus on 1 or 2 areas in ML, and then say that, okay, well, you don't have to get into deep learning if you're doing fun stuff with ML. But invariably, most companies are moving into deep learning because they're sort of, they're making better approximations and helping you. And then you can start looking, okay, so fine. I mean, yeah, text and analytics and NLP is huge areas. So you're jumping into n-grams and then doing other sort of word-to-vec, word-to-vec-to-word, those kind of things. And you can lose days and weeks. I've gone through that as well. Then you can just jump out and stop. So you have to continue to find ways to kind of, creating a small sort of a pool of choices despite all the distraction and probably also temptation. That's a big problem. You get tempted because you see some implementation and you want to make it better. You make it a little bit better, you share it with someone, that becomes huge. So I would say avoid temptation and avoid distractions, which actually sometimes temptation is distraction. The next step is to just pick, I would say it's almost like climbing a hill. So basically you're picking some stuff up. You go to the ML hill, and then you take it up to your deep learning sort of a plateau, and you can come back and revisit whether totally on the fundamentals of your statistics and probability and advanced math. If you want to move into, for instance, you're doing capsules, you may want to study more about geometry, complex geometry, curvature, sort of mathematics. So you can revisit that, but don't think that, okay, let me get that thick book, 800 pages, and let me fully understand it. That's the wrong approach. I have like 50 books in my MacBook on my dock. I just open up for reference. So I just say, okay, fine, I like this. So then finally, I think in your mental map, you will be able to create That's how I at least work, is I have a mental map. It's like a, a virtual sort of repository of things. So I make connections with how can I make it, anything that I do, does it make sense in any industrial application? It could be anything, right? It could be, well, it's cardiovascular or lung or heart disease. That's where if I have some data, what do I need? So I look at what is the output. When there is an output, I really don't care if I use a little bit of Bayesian or maybe totally nothing. And I don't feel guilty that I have to explain myself or others Bayesian, which I may or may not have fully understood or comprehended. Well, parts of it I comprehended well, which work for the solution pipeline. So to me, that works excellent. So for me, that is my reward mechanism. So just pick stuff up. So you have this hill, and then you have this cylinder. Just kind of visualize with me. So you have this cylinder that is a solution you're building at the end of the row. That solution has some meaning. It's not something like I did face detection and haha, you share on internet and people like it. That is a fake gratification. That's not real gratification, believe me. It gives you likes, but it's basically meaningless. If it's finding application in your office where you can take and say, well, I built something that makes sense, can we create a new, I don't know, authentication mechanism where people can use face and write something on a screen, and then we have a new way of authenticating, that makes some sense, it's something sensible. You can put it in a lab and let people test it. So I think that way you'll be really focusing well. And if you just sit around and say there are like tons of MOOCs, there's tons of books, and then I think you will be lost. So try to sort of simplify it, try to focus on the output, and if your output is always is a solution that has some hope of living in the form of an application somewhere, then I think you're on the right track. If not, I think you should just stop and kind of go back to the drawing board.
Yeah, it really helps. I think you've already given answer to the next question as well in this. So how do you achieve this sweet spot between theoretical and application-oriented learning?
That's the sweet spot. So for me, I was super interested I'm very interested in solving how, so I'm not saying capsule, I'm not like fascinated about capsules. I don't want to become a capsule dad or capsule great-granddaddy because I spent 2 years working on it and I was Mr. Theoretical, big guy. People gave me nice awards and I was super excited. No, for me, the most interesting thing is to understand if a computer is able to look at just a handful of my images and is able to look at this manifold space from a different angle, from the back of my skull, it can, with that limited amount of data, do the same stuff which huge amount of data can do. Now for me that is meaningful. To understand that, I said, okay, I want to understand Riemannian curvature. I want to understand Stiefels matrices. I want to understand the bunch of other sort of curvature mathematical derivations. So I focus on Riemannian, and Riemannian curvature is used actually quite a lot in image classification and isolation. In fact, I just recently, a few days ago, created a new folder of Riemannian curvature with different applications, and some theoretical, but some are practical applications. So then I just focus on that area. And so then I'm taking a very complex theoretical subject, advanced geometry, and then take it into an application so I can say, what can I do, and take it into improving capsules so it can solve that project of histology, in which it can map the texture of the photo taken of a breast mass image, and see if it can see and understand and break the texture and rotation. Those are the kind of the different features which capsules is using. So I try to make practical sense out of it. Then I stay in that sweet spot, which is hardcore stuff, but just picking nice things, understanding that, and applying it into the practical world of, oh, can I take it? Maybe I'll take it to that project and see how it works. If it fails, it fails. If it works, wow, that's how you actually make discoveries, right? People stumble into discoveries. And that's probably the best way to do it. You wouldn't survive in theory anyways, right? You get bored and you give up. So basically, I would say, don't find this way of kind of, standing and taking theory and applying it, failing, apply again, take a break and apply again.
Cool. All right. One last question, and this is a personal one, right? So we saw you talking about a lot of different initiatives that you're working on, different collaborations, right? So how do you decide the priority of what problems warrant your attention right away? So how do you prioritize what are the problems that you want to solve today and tomorrow and then in a month? Is there an algorithm there?
No, I think it's again the viability of that specific project. So, I keep getting approached by really good friends, or some people are thinking of an amazing sort of algorithm using neuroscience to create kind of, spotting, encouraging, building skills of talent. For example, if you're going for an interview, how's your body language, how are you speaking, and then eventually taking that information, if you take thousands or 100,000 of those videos, you already have a huge data set. But I said no to him, no matter how. So it was, and one was obviously the capacity problem. I just don't have, I'm now maxed out. I have 3 startups, and the ones that I showed you, and then the venture fund, which we're setting up, is a huge exercise. So that is for me a way to control that. Because beyond that level, and the other is that my own people are getting really super pissed at me, because if I say, well, I'm not able to be there in our own regular conference call to maintain the continuity of the dreams that we set out, because I have to give importance to someone else, which is an exciting project, is a way to also shut down. So max capacity and also prioritizing. And the viability, then I can look at the viability if it's operating in the zone where I'm working, because my physical limitation will just disallow me to work in something really exciting. So, I totally don't take advisors on board of my company, because I hate clutter. I don't believe in that structure. Many people believe having 10 advisors. I just, I'm pretty sort of straightforward with the way I want to do things. I don't sit on advisory boards. People keep reaching out. We are starting. I said, no, just don't use me. Why do you want me as an advisor? So the best way to scare them away is say, okay, I need $100,000, and then they just don't respond. That's great. Because people do give equity. People just don't even know. I said, why are you giving me 5% equity? I don't want. I said, maybe it means nothing. Maybe it's like $20 million. So that's a wrong way to attract people. So for me with the capacity, I think the problem with when you're at high capacity, then you really become very efficient. There's no other way to do it. The problem with organizing your time and work is when you have 50% capacity, then you start wasting and playing around your time. So I think max capacity is really an easy way to kind of sort those problems. So for me, running 3 companies is a huge task. If you want to do a venture fund with these companies where we're already getting these guys in, then I need to delegate the task. I need to get general partners who need to manage those companies, need to have funding. And so at some point of time I'll gravitate so I can still continue visibility, but I think physical limitation, there's no way, you can fight that.
Okay, we're open for 2 questions. So we have a question here.
Hi, great talk, Nikhil here. You spoke about image recognition and RNNs for time series and text data. Is your company working on structured data in terms of deep learning? Because most big companies have structured data. So is there
Yes. We as a startup, we are not yet. So we are purely focused on deep learning, and we are really going really hardcore focused on health tech, in healthcare. So we are working right now with a few companies, although we are also working with telcos, and it's all purely essentially, and they ask these questions as well. So it's fine, getting cats and dogs pictures and playing with it is fine, but how can I apply it to my base stations if I'm a telco, right? Base station collects a whole lot of data. So what I have done, I have practically worked in those areas where doing some interesting stuff with machine learning, unstructured data. So I was giving one example yesterday on end of life of hardware systems within, and I think someone asked yesterday on, well, what do you do with Dalton log data. Log is kind of still structured data. It's kind of, actually text data, which is just, thrown into a text file. You can put all pipe sort of select or pipe icons, and you can still structure it and bring it into your tables. But there are ways to start connecting your structured data, which is still inside of, for example, let's say information about a big company like, I don't know, Reliance, right? They have like thousands and thousands of vendors and vendor ecosystem. People supply, from, shipping, stationery and lots of other things. So NLP can be totally applied, it can be applied into every contracts and procurement principles and everything that you have. It's a whole lot of text there. You can really apply it, you can start finding patterns already. So you can make predictions already on, which contract is, for example, legally has loopholes. Because, when you're a big company with matrix organizations structured across the world, you would probably not know where things could potentially go wrong. Not always things go wrong, unless there's a huge litigation coming in your direction. You have no idea how. But in contracts, you can already start sort of looking at IP, intellectual property, looking at other things, and try to understand, okay, so where do we stand in this, and why are we contractually in agreement where we have mutually signed those things together? So there, NLPs like some people should do that. So I think if businesses, and if you know any businesses who are open to do this, and I just touched a very small domain. I mean, if you sales, balance sheets, so you can use a whole lot of stuff in balance sheets as well, right? In the annual reports, like hundreds of pages. You can already start taking that information, including the internal information, which the company should be able to provide to you with that structured information already in silos. No one knows. Left hand doesn't know what the right hand does. But then your job could be to get that information to start making correlations. And then the magic is this. So you have sales data, you have finance data, and then let's say you have in silo, you have made some pattern and understanding. And some correlations, internal correlations actually don't mean anything. They basically are self-referencing, right? So basically it's still like, okay. Now, when you have those data, you can provide a holistic solution. And that's what we want to do with LE, is to start kind of finding correlations and then predicting events in terms of, it could be anything. So there are sometimes a budgetary kind of a cycle can be influenced by your sourcing principles. When you take, let's say you go to a different market, you go for raw materials. So these are problems. I think really enterprises should really be saying, okay guys, I mean, in confidence, we're going to kill you if you take our data outside. There's another new contract is signed. and then I think they should provide this information to ML engineers. So I think really that's a great opportunity, but a great question. You should be able to start already making a hypothesis of understanding. So, and for example, a whole lot of stuff, things have been written on paper. Get the OCR stuff, move that into your digital value chain, and then eventually start using ML. I've done that with banks, and I'm not at liberty to give examples, but in generic, I can give you examples of reducing sort of churn, increasing productivity by just looking at very simple into your typical brick and mortar. You call for, okay, will you buy another insurance product as compared to the digital behavior of customers, which is sort of total different way they operate, different way they behave. The same customer you spoke to on phone, and then making correlations and selling them the right product, which he didn't tell you on phone, but he alluded to when you saw this behavior going on social media, doing this, doing that, and all that. So that we've been doing for banks for a long time. So there's a lot of play in ML, and hopefully also deep learning with RNNs.
One last question.
So, but great question actually. Really good that you asked. Don't really ask those questions. That's the gentleman there.
Hi, I am Jitu Mehta. One of the major things that is now developing as part of deep learning is that first thing you do is make your network bigger and deeper. Your people basically try and train a bigger and bigger and bigger model. It's like the way originally the cars used to be, like you add CCs to the car so that it becomes faster and better. Okay. Now, one of the key presumption says that somehow you have a whole bunch of data here, X and Y, and you predict a gigantic function which is spread across the so many layers. We don't really actually know anything about what those W's actually mean in semantic terms. So like one of the basic question really comes down to is that how do you interpret W's of a network X versus another W's of network Y, which predictably does similar job, but they don't really have any correlation between their own weights, matrix, etc. So the question really is that does interpretability of the W's or interpretability of the weights or a model itself is really relevant, or should we just say forget about it, I don't care, and we should just be happy about the result, or should we really care and say that like, why I am not able to actually make sense out of those W's? That's what we should try and actually get more research into.
Yes, so basically you talk about weights, right? Is that what you mean, right?
Any model which you can actually train, which should it have interpretability, and are there ways to get interpretability actually in place, or should we actually directionally forget about interpretability of the model itself?
No, I totally agree with you. You're alluding to a very important point, and the discussion that we have in enterprises, not just interpretability, but also explainability. So in many cases, and I think in saying that, well, you know, these are our models, this is how it works, is not the way to take to a client who may or may not raise this question to you. I think your goal should be to focus on really interpreting it yourself and understanding, well, why are they not relatable? Well, you know, there are some things we already know, right? It's not like you can endlessly keep building deeper layers and more layers. So you know that already. So, you know, there are ways to test it as well. There are many ways. So there's one research I actually sort of also, I think I haven't even made it a public or my project, in which we were looking at, you know, people make assumptions and they make those assumptions, write a research, and then suddenly the whole deep learning community starts using that research. So in a way, I had kind of competed and I actually disproved that paper by just using the same things. So I said, okay, well, I don't think this, I agree with this. The more I started adding more layers to it, that model started failing. And then I started also comparing it to different optimizers. So this is more an optimizer sort of discussion. That is also an important sort of decision point when you say, well, which works better and which doesn't. There is some level of mathematical understanding how they are built, and that's why you say, okay, like I said, you know, ReLU, you should not just assume that it works. You should try to find better ways to improve it. That's one way to solve the problem. But definitely, if you're not understanding what you are actually improving on, is still sort of, I agree, flying still in the dark. And explainability is a very important aspect as well, because you need to be able to explain, not just for the sake of, you know, the client or the project that you're in, but also because, you know, from at least from your region, you have to really explain your model and your algorithm. GDPR is like, so I don't know how it is in APAC, but you have to explain it because, you know, the implications have really far-reaching consequences. So that dismissive approach, which many deep learning, sort of even some top level, I know some of my peers have also spoken in conferences that, well, don't worry, that was the Wild West days a couple of years ago. I think it's now to take responsibility to interpret these and actually even start finding reverse engineering and to first understand, then interpret, and then explain. I think those three steps are still missing. So I think there we definitely need to do a lot of work. So we're trying to do it.
Can you give any concrete example of some of the work you have done in this area?
So I can have shown also with code, I could have shown you which I tried to disprove, in which where, you know, there's a certain direction in which you start using just a bunch of optimizers and everything else is ignored. And then, so in there I disproved it by, what I actually did was starting to run various optimizers based on these sort of extra layers and using all these different weight matrices that were, or at least the distributed weights that were from these learned models like the transfer learning models. So there I actually sort of, it was more like a a way to disprove that it is per case basis that you should be able to look at the optimizer. So the optimizer, I can give a more detailed explanation if you're interested later with that code. So that is the only way you can actually disprove or prove and agree, and then say, okay, well, that's the way you wrote. I agree with you, and then we can start looking to improve on it. So from interpreting a whole neural network and a bunch of neural networks, so you're babysitting model A, model B, model C, and then your weight distribution matrix on each is very different. Well, we know how basically we have defined the neural network weight distribution, right? That we know, right? We need to start extremely small. We know that, and we don't want to sort of play our own heavy hand, because then, well, you don't need a neural network, right? If you say, well, I give it weights before I fire the network, I say, I give a weight of 0.7, then I would say, well, there's no need to put in hidden layers. You can just say, well, it is 70% or aggregated, and then that's the solution. So the whole idea of the theory, the logic behind weight distribution is definitely makes sense. But understanding the variations and the slip edges and the differences when we start using different models, we definitely need to be able to explain these. So it's something that is not being really widely addressed. I hope and I wish it was. But we are being challenged as well. And on optimizers, I showed that at least some in private conversations before we write our paper. But definitely it's something. And explainability, which you didn't address, but I think people also asked, well, you need to be able to explain how it works and what implications it will have and what does this mean. And that is also missing.
Cool. I think Tarry will answer a few more questions during the open networking event, right? So I think over to Judy now for the closure of the event.
Thank you, Shweta, and thank you, Tarry. I must say, Tarry, your years of experience, depth of knowledge, and ability to present in such a way has created one of the most memorable evenings. Your passion for work, willingness, and commitment to give it back to the society is unparalleled. I would like to thank Tarry on behalf of each and every one of you. I would also like to thank each one of you for being a valuable member of our community and coming here tonight for making this event a success. I would like to extend my thanks to our education partner, GreyAtom, media partner, Your Story, and venue partner, ISME. So before we proceed for the networking session, I would like Shweta, to present a small memento to Tarry.
Hey, I guess that's good, guys.